Good morning, everyone. Welcome to Session 2 in the Climate Basics of the High School Climate Change Symposium. This session is being recorded. Our speaker for the session is Professor David Karowe from Western Michigan University. Dr. Karowe's students are investigating potential ecological consequences of elevated atmospheric carbon dioxide. Dr. Karowe's lab is looking into how the nutritional quality and defensive chemistry of plants change under elevated CO2 and how such changes affect the growth, survivorship, and behavior of insect herbivores and parasitoids. The ultimate goal of this research is to expand understanding of the ecological and evolutionary consequences of elevated CO2 to include higher trophic levels. This work has been supported by grants from the National Science Foundation and the United States Department of Agriculture. Thank you so much for coming, Professor Karowe.
Thank you, Riley. Just a disclaimer, I won't be talking about my own research today. I'll be talking more generally about climate change in the Great Lakes region. And instead of talking about insects and parasitoids, we will talk a little bit about fish and birds and trees. So if you don't like bugs, no problem. Okay, so I will start. Let's see. Okay, so we'll talk about climate change in the Great Lakes region, starting with the question, has it been changing? Or how has it been changing? And just to a heads up, sometimes I'll use GLR to mean Great Lakes region, kind of depends on how much space was on the slide. First thing I'd like to do is look at a video that shows, that is an animation of thermometer records from around the world, starting in 1880 up through today. This is put together by an institute that is part of NASA. And they just took the thermometer readings from all over the planet and averaged for every place where there was a reading, averaged over 5-year periods, the temperature for that place during that 5-year period, and then asked, was it warmer or cooler than the average temperature for the same place during the 30-year reference period, basically middle of last century. So what we can see is in the 5-year period, 1880 to 84, there's a lot of blue. Most of the world was cooler than it was during the middle of last century. But by watching what happens over time, we can see, and especially if we look in the Great Lakes region, we can see how temperature, one major component of climate, has been changing if it has. Okay, so the years go by pretty quickly at the bottom. I think that's an absolutely unarguable demonstration that climate has been changing globally, but also within the Great Lakes region, that just focusing on the temperature component. What you almost certainly noticed was there was a general increase in temperature. Since 1895, Michigan's warmed by about a degree Celsius. Doesn't sound like a whole lot, but the difference between average temperature today and when Michigan was covered by half a mile of ice during the last, let's call it ice age, that was only 5 degrees C. So 1 degree Celsius is a huge thing for our planet or for our region. So you probably noticed 2 things. One is, yeah, the map turned orange and red. And second, it did a lot more of that in the last several decades. And you'd be right. Since 1975, our region, Michigan, or actually our state, is warming more than twice as fast as over the entire thermometer record. So climate change is happening and it's accelerating. It's not just land that's warming, waters are warming also. The surface waters of the Great Lakes, everywhere that there is a color here is a place where NOAA's surface buoys have detected a significant increase in temperature. Some of these rates of warming are really dramatic, like the red here in Lake Superior over a 20-year period. That is about um, a 10-degree increase, 10 degree Fahrenheit increase in surface temperature. We'll get back to the consequences of lake warming in a little while. One of the physical consequences, not ecological, but physical, is it's harder for ice to form. And not surprisingly, we've had a lot less ice on the Great Lakes, 70% less since 1973. And in fact, we had virtually none until this polar vortex hit this year. We were on a record low pace. That means there's more lake effect, snow and precipitation, at least in the short run, because that stops when the lakes ice over. Okay, so temperature's been changing. We've clearly been warming at an accelerating rate. Precipitation is the other big component of climate. And we have seen an increase overall in average total annual precipitation, an increase of 5 to 15% throughout most of the Great Lakes region. Unfortunately, a lot of that increase is in the form of more and more powerful extreme precipitation events, okay? Huge rainstorms that put water onto the surface a lot faster than the ground can absorb it. So it moves across the surface downhill. Of course, water will flow downhill and pools wherever there are low spots. And we call those pooling events floods. So we've had a 42% increase in severe precipitation events in the Midwest, including Ann Arbor, Grand Rapids, flooding events in Ann Arbor, Grand Rapids, Kalamazoo, East Lansing. Pretty much the whole state has been hit by more flooding as a result of greater severity and frequency of these severe precipitation events. Basically, they happen because if you warm the air can hold more moisture. And it can hold about 7% more moisture for every degree increase in temperature. And that means if there's more moisture in the air, there's more moisture that can fall out of the air. Okay, so how have, if at all, species and ecosystems been responding to the climate change that's been happening in our region? One of the groups of species for which we have long-term records and therefore can see have they been changing over decades is migratory birds. People have been marking down the first day that they saw one of these return in the spring. And that has led to a very clear pattern that most of the migratory bird species in the Great Plains region, at least, are arriving earlier. And most of them are arriving on average, about 4.5 days earlier in the spring than they did 1910 to 1940. So this is their arrival date, 1910 to 1940. This is their arrival date, 2000 to 2012. The dotted line indicates that no change. Every dot is a different bird species. Most of them are below the line, indicating they are arriving earlier than they did at the beginning or early part of last century. But arriving earlier doesn't mean that you are keeping pace with climate change. And it turns out that actually most of the our migrating bird species that migrate long distance or medium distance, even though they're coming back earlier, they're not coming back earlier enough. So they're actually arriving when spring is more advanced than it used to be. Only the ones in this blue box are really keeping pace with climate change. So we do definitely see a shift in timing, but it's not enough of a shift for most species. Other things are shifting their spring timing, most notably trees and other woody plants, the time when they put out their first leaves in the spring, which is called spring bud burst, is happening earlier than it was middle of last century. Every place with an orange or red dot is a place where plants are putting out their leaves earlier in the spring. Nobody has really been able to explain why the southeast plants are responding differently. But clearly within the Great Lakes region, plants are speeding up their spring bud burst. They're also moving. The other big response to climate change, it's harder to document, but the other big response in principle should be move away from the equator, move to where it is cooler. So move towards the poles. In our part of the world, that means move north. And it turns out that about a third of tree species east of the Mississippi have shifted their ranges significantly north. Every arrow is a tree species. The green arrows are ones that moved in a direction that included a significant northward shift. Not directly north necessarily. In fact, none of them moves directly north. More are moving west than north, but the green arrows indicate species that have at least been moving north as part of their movement. And what you see, actually, sorry, I'll back up. What you can see is that most of the arrows are not green. 35% of all of these arrows are green. And the ones that have been shifting north faster are ones that are pollinated by wind, like oaks. The ones that haven't been doing a very good job of redistributing themselves across the landscape are tend to be animal pollinated, like the maples, including sugar maple. Okay. So if 35% have been shifting north as part of their shift, maybe not even most of their shift might have been west for who knows what reason. But if they've shifted north in part, that means that 65% have not, if 35% have. And even the ones that are moving north the fastest are not moving north fast enough to keep pace with the moving climate. So are we seeing responses? A minority of species show responses. Even those that are showing responses, the response tends to be not sufficient to keep pace with a moving climate. But we definitely are seeing species and ecosystems in the Great Lakes region recognizing or responding to climate change. So let's look into the future now. What's going to happen with climate change in our region? Really important thing is it depends on choices that we make. And there are multiple futures possible to us, and especially to you guys. So for high school students, I think of what we're going to talk about now as describing different futures that are possible for you. One of them, you will get one future. Right now, you're being given a future that is a pretty bad one, quite honestly. But that doesn't have to be your future. We have various possibilities still available to us. And so I'll talk about two, and where possible, three possible futures. I'll refer to them as business as usual, Paris Agreement, and Paris Extended, just to orient you on this figure. And this figure highlights some of the choices, three of the choices we have. The really important part of this slide is right at the beginning. The magnitude of climate change this century depends on our choices. You will have a say in what your future is like. You can have a big influence or you can have a teeny influence, but it is a choice that you can make. So let's look at these three choices, three possible futures, in the context of the last 400,000 years of atmospheric carbon dioxide levels. They've gone up and down with the temperature cycles, never got above 300 parts per million until about 1950. Today, they're about 415 parts per million CO2. So our question is, how much higher are we going to let atmospheric greenhouse gases, in particular carbon dioxide, go? And that's tantamount to choosing what future we're going to have. The pathway we're on, appropriately labeled business as usual, If we keep doing what we are doing, which includes shifting, but very slowly, to non-fossil fuel energy, by end of century, we'll have about 950 parts per million atmospheric CO2, and Earth will warm about 4.5 degrees Celsius. Remember the last time, well, when Earth was 5 degrees, about this amount of temperature different, but in the opposite direction, 5 degrees cooler, southern Michigan was under half a mile of ice. So this is has an immense effect on our planet. Another option that's being discussed, and of course our current administration returned us to being part of this Paris Agreement, is we'll keep atmospheric CO2 no higher go no higher and level out at 550 parts per million. As a consequence, we'll keep global warming to 2.2 degrees. Paris Agreement says, hey, if we can, we're going to limit warming to 1.5 degrees above. This is all relative to pre-industrial temperatures. And I call that Paris extended future. And it requires that we either not allow carbon dioxide to get above 450, or if it does get above, we figure out a way to pull it back down. So we'll talk about what your lives might be like if this is your future, or if we switch over to this future, or better yet, the Paris extended future. Let's first compare business as usual and Paris Agreement in terms of extreme heat events. And in this case, a season-long extreme heat event. What's the probability that in the future, by 2070, that a future summer will be hotter for any place on the planet than its current record hot summer? The answer is, under business as usual, if we just focus on Michigan, it's 90%. So here's the global prediction. Any area in red is predicted to have 90% or more of its summers be hotter than the record hot summer by 2070. Of course, it would start before then, but by 2070, it would reach 90% of summers that are hotter than our record hot summer. Life would be very different in our region and, of course, across the planet. Agriculture, among other things, would be very difficult. Would Paris Agreement prevent any of that? Yeah, it would prevent an awful lot of it. Under the Paris Agreement, for our region, it could be as little as 10% of future summers hotter than our record hot summer. Could we still grow the crops we grow today? Probably. Could we still raise the livestock? Yes, probably. Would species still survive? Probably. Okay, if we look at the actual summer temperatures for the Great Lakes region predicted under business as usual, the prediction is summers will warm by 6.5 degrees. If you remember, the global average warming was 4.5 degrees. So our region warms substantially more than the global average. And unfortunately, the prediction about the other big component of climate, precipitation, is a pretty big decrease. 10% decrease, especially in the face of a massive increase in temperature, would be probably disastrous. So under business as usual, large temperature increase, large precipitation decrease, that's not a very happy future. Would Paris Agreement make any difference? It would cut the warming by about half. So our region would warm about 3.5 instead of 6.5 degrees, and it would remove about half of the decrease in summer precipitation. So less warming, less decrease in summer precipitation. Life in summer would be able to continue much more like it is today than under the business as usual emission scenario. Obviously, a Paris Agreement would create much less stressful summers for all kinds of species and ecosystems, and of course for humans as well. Droughts are the most deadly of extreme events for things on land. I see every once in a while that maybe a question has been entered. My preference is to take questions at the end. So by all means, enter your questions whenever they occur to you. Riley will go through them and I think serve as the MC for questions at the end. Okay, so droughts are the most deadly of severe weather events for life on land. What we'll do is look at the probability or the severity of droughts. You can see the whole world, but we'll focus on the Great Lakes region. Under 3-degree warming, which remember is not business as usual. Business as usual is 4.5 degrees. But even under 3-degree warming, what we see is an awful lot of red and orange, which is a 300 to 500% increase, or 3 to 5 times increase in the severity of droughts relative to historical droughts. So those under even 3-degree warming, our region is going to have many, many more very damaging droughts, much more severe droughts. Paris Agreement gets rid of almost all of that increase. There is warming, but it is not enough to cause an increase in drought severity. You can see as much blue which is actually a predicted decrease in drought severity, as warmer colors. And under Paris Extended, it's even better. So anybody interested in agriculture or ecosystems in our region, this is a really strong argument for getting off of our business as usual pathway and onto a better pathway. If we look not at droughts or extremely hot summers, but extremely hot days, and ask how many days per year will we have over 100 degrees, we can actually look at predictions for specific cities, including Kalamazoo. Kalamazoo currently has 0 days in an average year over 100 degrees. Under business as usual, the prediction is there'll be 9 days per year by mid-century, 14 by 2075, and basically a full month of days over 100 degrees. Not necessarily in order, but for sure there will be a number of those consecutive. So that's a huge increase in extremely hot days. If we ask, well, would Paris Agreement make any difference? By end of century, instead of 30, it would be 20. Paris Extended, instead of 20, 30 or 20 would be 11. So we'd still have an increase in these extremely hot days, but nowhere near as large an increase. We could ask what's going to happen during the winter, and a huge change in the winter will be that the precipitation that does fall isn't snow anymore, it's rain. So what we think of as a typical winter day will become more and more a rainy day. Historically, this is a map showing the percentage of winter precipitation December through February that fell as snow. And for a good part of our region, at least what we consider the snowier parts of our region, it was 60 to 80%. The prediction under business as usual is that 10 to 30% of our winter precipitation will be snow, 70 to 90% will be rain. This is quite a worrisome prediction for anybody who likes skiing, snowboarding, cross-country skiing, of course, and also for the industries that rely on snow. I don't have a corresponding prediction for any other potential future business, Paris Agreement or Paris Extended. Okay, so we've seen some of the choices we have for climate, future climate in the Great Lakes region. Now let's ask, how would those different possible futures impact species and ecosystems? I think the aquatic ecosystems are the ones where it's probably easiest to predict who might benefit and who might suffer. We call them climate winners and climate losers. And the basic rule is, if you like warm water, if you're a warm water species, you're probably going to do well, at least throughout most of the century. You'll be a climate winner. But if you like cool or cold water, you're not going to do well. You'll almost certainly be a climate loser. Okay, what kinds of, in the Great Lakes, what kinds of fish species would fall into the category climate winners? Oh, carp, bluegill, catfish, perch. Not our sport fish. Where do our sport fish fall? They fall in the category of climate losers, and some of them huge climate losers. Whitefish, trout, all the trouts, walleye, all the salmons are cool and cold water. They're deep water fish. And as a consequence, they are very likely to be climate losers and maybe massive climate losers. That's just based on water temperature. One of the things that is not included in these predictions about the fate of fish species um, is something that I think may affect deep water fish or sport fish even more. And that is that towards the end of the summer, the deeper waters in our lakes may not have enough oxygen for them to survive. Their temperature tolerances means they can't come to the surface because it's too warm. So they are in danger of suffocating at the end of the summer if there's not enough oxygen in the deep waters. Why might trout, salmon, whitefish, walleye, why might they suffocate? Because our lakes have what's called a summer stratification period. Oxygen gets mixed down into the deep waters in the spring, basically when the ice melts. And then there's no more mixing of oxygen down to the deep waters until the surface waters cool enough in the fall. And then the lake can mix again and oxygen can get down to the depth. That means that whatever oxygen is mixed down in the spring has to last until more oxygen can get mixed down in the fall. The time period between the spring and fall mixing events is called the summer stratification period. Same amount of oxygen is going to get mixed down in the spring mixing event, but that's happening earlier in the spring. Ice out is happening earlier. The lakes are cooling down later in the fall, so the summer stratification period increases. The prediction under business as usual is for Lake Superior, it's going to increase by almost 3 months. For Lake Ontario, 2.5 months. For Lakes Michigan, Huron, and Erie, about 2 months. Will the oxygen be able to last that much longer? I think it probably will not. And I think what we will see is a large increase in what are really mass suffocation events of our deep water, our cold water fish, because their oxygen runs out because the summer stratification period is now too long. Under Paris Agreement, what would happen to that increase? It would basically decrease by about half. So Lake Superior, summer stratification period would increase by 50 days. Lake Ontario also, but for Lakes Michigan, Huron, and Lake Erie, it's about a month instead of 2 months. Would that prevent mass suffocation events? I don't know. Certainly a better chance than under business as usual. So we may be able to keep our sport fish in the Great Lakes region. Inland lakes that are not so big also have summer stratification. Also, their summer stratification will increase under business as usual by 35 days, Paris Agreement by 24, Paris extended by 15. So deep, cool water fish in inland lakes are also likely to benefit quite a bit from getting off of our business as usual future and getting onto Paris Agreement or Paris Extended. For flowing water systems, so streams and rivers, a huge impact of climate change will be by altering, so of course stream temperature, but also by altering what we call the flow regime. And in general, climate change is going to make flow more variable. There will be more high flow days, typically in the spring, when things could get dislodged and displaced downstream. There may be a problem, but not a huge problem for aquatic flowing water, aquatic ecosystem species. Under business as usual, prediction is 80%, 86% increase in high flow days. Under Paris Agreement, a smaller increase, but still an increase. I think for flowing water systems, the real danger is the low flow days in the summer when the water gets stagnant, it gets very warm, its oxygen levels go down. Low flow days are likely to be much more deadly than high flow Under business as usual, the prediction is about a 50% increase in low flow days for Great Lakes, rivers, and streams. Under Paris Agreement, basically no increase, 3%, undetectable. And I think that's the big benefit of the Paris Agreement for flowing water ecosystems. One of the other big benefits for both lakes and rivers is a Paris Agreement effect on decreasing toxic algal blooms. Warm waters that are getting a lot of runoff from extreme precipitation events are very likely to have, much more likely to have a toxic algal bloom. This is a toxic algal bloom in Lake Erie that a couple summers ago that required Toledo, the city of Toledo, to shut off its water supply because it was coming out of the lake. And these algae, or it's actually a cyanobacterium, secrete toxins into the water. They kill fish. Pets can die if they go in the water. Humans, of course, should not contact the water or ingest it. And the algae that cause these blooms have a competitive advantage in warmer waters. So the prediction is we'll see a big increase in toxic algal blooms. Green is areas where there's predicted to be an increase. In our region by 2050, a much larger increase by end of century. So that really does, really degrades our aquatic ecosystems. Forests are a big part of the Great Lakes region. And if we ask about individual tree species within Michigan, under business as usual, Forest Service predicts that of our 20 most abundant tree species, 13 of them are predicted to decline quite dramatically by at least 50%. We won't have paper birch, except very little up in the UP. We won't have aspen, except in the UP. Same thing with balsam fir. White cedar, white pine, sugar maple, all of those decline, basically disappear or at least decline dramatically. Under Paris Agreement, we don't lose 13 or almost lose 13, we only almost lose 9. And two of the ones that no longer decline by at least 50% are two that I consider kind of symbols of Michigan trees, sugar maple and white pine. They remain healthy. Would southern Michigan have sugar maple? If you grandchildren grow up in southern Michigan, will they see sugar maple? Yes. If we do Paris Agreement or Paris Extended, if we do business as usual, very likely they would not see it. As the forests go, so go the birds in many cases, or many birds are forest dependent. Under business as usual, these are also Forest Service predictions. 24 of our Michigan birds would decline by 80 to 100% under business as usual by end of century, including all of the ones on this slide. Paris Agreement, instead of 24, it's 10 that declined dramatically. Of the ones that were originally on the slide, these 5 no longer decline dramatically. Your children and grandchildren would have the opportunity to hear a wood thrush. But not if we continue along our current path. If we choose the business as usual future, then yeah, that wood thrush is gone, at least from southern Michigan. And there are a lot of other species that the Paris Agreement would preserve for Michigan that would be lost or almost completely lost under business as usual. And Audubon Society also has done a lot of predicting about the effect of climate change on bird species. And you can actually go to their website and look at predictions for specific zip codes. So 49009 was one of the zip codes. And you can see this sort of prediction under 3 degrees. Remember, that's not even close to business as usual, but that's the highest level of warming they have modeled. Under 3 degree warming, 13 species in a Kalamazoo zip code would be highly vulnerable, these guys. Highly vulnerable, probably on their way to at least regional extinction. Would Paris make any difference? Well, under 2 degrees, instead of 13, it's 5, highly vulnerable. Under Paris extended 1.5 degrees, it's only 2. So there would be local benefits, of course, to choosing a better future. In fact, if we back up and ask kind of from the biggest ecological view, what's the probability that any place on our planet or any part of the Great Lakes region would experience what's referred to as biome change? Earth has about 11 major ecosystem types: desert, rainforest, savanna, boreal forest. A change from one of, and those are called biomes, a change from one of those to another would be a massive ecological upheaval for any place on the planet. So we want to know, what's the probability that Great Lakes region would experience a biome change? And we'll distinguish between a moderate biome change, which would be like one kind of forest being replaced by another, the boreal forest above us, north of us, being replaced by the mixed deciduous forest of Michigan. That would be a moderate biome change. But of course, to anything that lives in a boreal forest, that's a major change. They probably, most of them, could not live in a deciduous forest. But a major biome change would be something like a tropical forest changing into something that's not a forest, a grassland, a savanna, which is predicted for a lot of the Amazon region under business as usual. And it turns out that the Paris Agreement would prevent almost all biome change within our region and actually globally. So 3 colors to indicate major, moderate, and in between biome change. Here's the prediction under business as usual by end of the century. Virtually all of the land surface, except for deserts and the Greenland ice sheet, is at risk of at least moderate biome change, including virtually all of the Great Lakes region. This is a future where this part of the world doesn't feel like this part of the world anymore. Where the way I put it, Michigan doesn't feel like Michigan anymore, doesn't feel like home. It would be a different biome. Paris Agreement takes away almost all of that biome change. The world still feels like the world it is today, and most of the Great Lakes region still feels like it is today. So I would say still feels like home. What about human health in the Great Lakes region? Heat is obviously can be a challenge for human health. And just to remind you that the amount of heat stress humans will feel, and of course other species, depends on our greenhouse gas emissions, choices we make. And the choices we make in the next few decades really determine heat stress for the rest of the century. So we really have to get moving if we want to move away from, we have to get active if we want to move away from this kind of future. This is our business as usual future, to a Paris Agreement future, or better yet, a Paris extended future. Okay. So one of the things to ask is, well, these are average temperature graphs. Will average temperature really matter? Will it be change in extreme temperatures that will matter the most? And I think for life forms in general, including humans, it's what happens to extreme temperatures that will matter the most. So let's take a look at extreme heat and human health. First of all, when we're talking about human health, we really want to talk about heat index rather than just heat, just temperature. Heat index includes humidity as well. Why humidity? Humidity affects our ability to cool our bodies by sweating. The more humid, the less effective we are at cooling our bodies by sweating, and therefore the more at risk we are of overheating. So heat index is a better indicator of human health impacts than just temperature. At a heat index above 100, it's dangerous for children, adult, elderly, pregnant women, and anybody with underlying conditions to spend any amount of time outside if the heat index is above 100. If it's above 105, it's basically risky for anybody, healthy or not, to spend a lot of time outside during that day. If it's off the charts, we don't know. We haven't experienced that sort of heat index. And so for sure, it would be very challenging for human health. Exactly what it would result in, we don't know. Probably many, many hospitalizations and deaths. Okay, so let's take a look at heat index versus temperature. Let's suppose the air temperature is 100 degrees and relative humidity is 60 degrees. To us, it feels like 129 degrees. Anything above 137 or so is considered lethally hot to humans. So big point is it's not just temperature, it's temperature plus humidity. So heat index is what we should pay attention to most for human health. Turns out that if we aggressively reduce emissions by enacting Paris Agreement, then we substantially reduce the number of days where there's an extreme heat index in the Midwest. Number of days per year on average by 2085, and the heat index along the x-axis historically. So black bar is what's happened over the last 50 years. Historically, the Midwest, which includes states south of us, have had on average 6 days per year with a heat index over 100. Prediction is the red bar is business as usual by 2085. That goes up to 53 days, more than a month and a half, almost 2 months per year of dangerously hot days. Paris Agreement cuts the business as usual future by about half, 27 degrees, 27 days per year. What about heat index over 105 when it's dangerous for anybody to be outside? Okay, 3 days per year historically, up to 38 days per year under the pathway we're on, the future we're headed towards, but only 15 days per year under Paris Agreement. No prediction available for Paris Extended, certainly would be less than Paris. What about days that are above the known physiological tolerance for humans? Historically, none in the Great Lakes region. 7 days per year, when it very likely would be lethal to spend any time outside under business as usual to under Paris. We can ask how many days per year would there be or what cities would experience at least 30 days per year where the heat index is above 105 degrees. Okay, dangerous for anybody to spend any amount of time outside. Under business as usual by late century, in the Great Lakes region, we have a lot of cities. All the red circles, including Grand Rapids, would have 30 days or more per year with a heat index over 105. Paris Agreement, there's only one city in southern Missouri predicted to have that be part of their climate future. So in terms of human health, definitely Paris Agreement would be dramatically better. For Chicago, specific predictions exist and actual estimates of mortality. Paris Agreement relative to business as usual. Under Paris Agreement, every year 450 fewer people would die of heat stress in Chicago by mid-century, and every year by the end of the century, 3,700 fewer people would die. So these are immense benefits of enacting emissions reductions as quickly as possible. For Grand Rapids, the Paris Agreement would prevent a little more than half a heat wave per year, 6 heat waves per decade, and very importantly, those heat waves that did occur would be shorter. They'd be 3 days shorter on average. Heat waves become exponentially more lethal as they continue. The early days are not so challenging, but as the heat wave becomes longer and longer, deaths increase very dramatically. So decreasing the length of a heat wave by 3 days would save lots of lives. If we ask, what's the probability that our region would experience a heat wave that is so extreme that it's worse than the worst known heat wave that ever occurred, which occurred in Siberia in 2010. So the question this year is the probability of a heat wave that is of unprecedented severity, worse than any known heat wave in human history. Under business as usual, there are places on the planet that are very likely to have that kind of heat wave happen routinely. In the Great Lakes region, it's definitely a possibility. Under business as usual, under Paris Agreement and under Paris Extended, the probability is basically zero. So we prevent the most lethal kind of heat waves entirely. We'd also prevent a lot of death. The Paris Agreement and Paris Extended would prevent deaths due to air quality. The biggest thing that decreases air quality in our region is coal-fired power plants. They pump out little particulate matter that gets into our lungs and then throughout our body and causes cardiovascular and respiratory problems. So if we were to enact Paris Agreement or Paris Extended, we would have to get rid of coal-fired power plants. We're phasing them out anyway, not fast enough. And that would have the benefit of preventing deaths, heart attacks and deaths that these coal-fired power plants cause today. Today, every year in Michigan, it's 1,100 heart attacks per year and 700 deaths due to coal-fired power plants, to the generation of electricity via coal. Every yellow dot is a coal-fired power plant. The red shows that county's mortality rate due specifically to the emissions coming out of the coal-fired power plant. Okay, Paris Agreement, Paris Extended, all of that mortality, all of that red disappears because we would not have those coal-fired power plants. Let's take a look at of the three options we've been talking, the best case on the Paris Extended and the worst case, business as usual, and just ask what would these look like for the rest of the century in terms of temperature? And the thing that I think this illustrates is that these are very, very different worlds. Your future is going to be one of these or somewhere in between. It's going to be something like one of these. Think of or watch this to see how much better the Paris Extended future would be. So years are going by here. This is just temperature change. The colors are actually Celsius, not Fahrenheit. So you can basically double them to figure out Fahrenheit. We see under business as usual, we're already starting to warm much more under business by mid-century under business as usual than under Paris Agreement. Sorry, Paris Extended. This is a world where there may well be wars over water between, for instance, Pakistan and India. Not so under the Paris Extended future. And now we're at the end of the century. Oops. We're at the end of the century, and it really is quite different. Your lives would be very, very different, very much better under Paris Extended than under business as usual. So we always should end. What I've tried to show up to this point is that there are multiple futures available to you, and we're heading towards one that's about the worst. So, but we don't have to have that be your future. Your future can be quite a bit better than what it currently is planned to be. The hope is that at this point you're asking, well, how can I help make that better future my future and my children's and my grandchildren's future? What can I do to minimize climate change? And quite honestly, the two voices that are missing from the call for action on climate change, the two voices that are incredibly important but are not loud enough yet, are the voice of the faith community. This is absolutely a moral and ethical issue. We are stealing your future. My generation should not be doing that. And the youth voice. Your voice is the one that will make the most difference. So I hope you're thinking about what can I do? What can my voice add? And the nice thing is you don't have to go out and invent anything new. We've got the solutions. We just have to decide to use them. So we can create a better future by implementing lots of solutions that we already have. One is, okay, if today most of my energy is coming from fossil fuels, what about if I just use less energy? I'm doing less damage in the meantime. So this is sort of a damage minimization technique. And it basically is practicing energy efficiency and energy conservation. Around your home, the most important things you can do, put weather stripping on your doors and windows. It's remarkably effective, cost effective, basically because you can buy weather stripping that's, okay, it's not the best, but it's effective. You can buy it at the dollar store most of the time. So $10 and you can cut down your electricity, your heating bills. If you're paying them, then definitely you want to do that just because of out of pocket expenses. But you also, it's a good thing for the planet. Next time you buy a car, buy an electric vehicle or buy an electric gas hybrid like the Chevy Volt that gets, if you're using the battery a lot, it gets at least 250 miles to the gallon, and you can charge for free in many places. Another thing you can do is change your diet. Eat lower on the food chain, eat vegan, eat vegetarian, or if you're going to still eat meat, take one meat out of your diet. Take beef out of your diet. Beef has a very high carbon footprint per edible amount. Chicken, much lower. So if you substitute a chicken sandwich for your next hamburger, you've cut down your meat carbon footprint by 3/4. So I think of it as that Chick-fil-A commercial where the slogan is eat more chicken. I think of that as a climate change commercial because if we all shifted if we stopped eating beef, and even if we just shifted on to chicken, we would be reducing our dietary carbon footprint quite a bit. Another thing that's under your control is your thermostat. Turn it a degree a week in the direction you really don't want to turn it. Turn it down in winter, turn it up in the summer. And of course, light bulbs and so on. Problem is, these are all great things to do. We should do them as much as we can. But that's not going to change the outcome unless we shift away from fossil fuels. If all we're doing is using or taking a little bit longer to use the same amount of fossil fuels, then any prediction, just make it for 10 or 15 years later, doesn't change the outcome, just changes the time when that outcome is reached. What we need to do to change the future is get policymakers to support smarter energy choices. I think our governor and our two senators are quite good on climate change. They could always be better, but they're quite good. A new representative from, I think, the 3rd district in Michigan, Peter Meyer, too early to tell, but he's sounds like to me like a very reasonable guy who will pay attention to the science, especially if his constituents tell him they want him to enact policy that is smarter and that protects your future. And of course, at the presidential level, we've had an absolute 180-degree turn in terms of climate policy. We're back in the Paris Agreement. We can start to be a leader again in saving your futures. Okay, what do our policymakers have to do? They have to create policy that lets us get 80% at least, 80% of our energy from smarter sources, carbon-free sources. I think it's a two-step process in general. It's create lots and lots of green electricity, carbon-free electricity by, for instance, solar, wind, geothermal can do it also. And then move everything we're powering by fossil fuels onto being powered by this massive amount of cheap and carbon neutral electricity. Could we produce enough green electricity? Absolutely. By solar, and we have 3 different solar techniques, including the panels, not pictured here, that can produce globally 100 times all of the energy that humans use in all forms today, if we wanted to ramp it up. 2 of those solar types can produce electricity all night long. The panels on the rooftops or solar farms cannot, but the ones that focus sunlight, use mirrors to focus sunlight, can. 100 times include, and the US could be entirely energy self-sufficient by solar plants in the Southwest desert. Wind, globally, we could produce 40 times all the energy that humans use. Michigan could produce 12 times all the electricity we use. The United States could produce about 20 times all of the energy we use by wind, mostly onshore, a little bit offshore. So we've got the capacity, we just haven't decided to use it. Really important thing to convince your representatives to create smarter policy is get on the street, get out in public, letting them know you want them to do that. And that is put your boots on the ground next time there's a climate march, next time there's a climate strike. There will be repeated opportunities. The more bodies in the street, the more our policymakers will pay attention to it. Even if you don't want to say anything, even if you don't want to chant, you don't want to carry a sign, if you're just there, you're helping out quite a bit. Okay, third thing is talk to people. Talk to people, let them know some of the things you've heard today, other things you know. Talk about the causes of climate change, the consequences, and the solutions. By the way, it is absolutely clear that humans are the primary cause of climate change, and virtually all climate scientists, experts, agree with that. The fossil fuel industry is propagating lies that say the scientists have not yet reached consensus. The scientific community reached consensus 30 years ago. And virtually all experts know that it is that climate change causes are primarily human. Okay, we've talked a lot about consequences and a little bit about solutions. Share this information with your friends, the easiest people to share it with. Share it with people that you work with. You don't have to have an argument. It doesn't have to be a contentious discussion. You can just say, for instance, hey, did you know that almost 100% of climate scientists say we are the major cause of climate change? I didn't know that. Or did you know that our forests will remain intact if we if we enact the Paris Agreement, but not if we don't? Just put it on the plate. You don't even have to have a discussion. It can sort of be guerrilla hit and run. I do that sometimes. So just put it on the plate, get it discussed so we don't ignore it. Very important to talk to people who don't think the same way as you. An increasing number, it's actually over 50% of self-identified conservative Republicans, the demographic that is least in favor of climate action in our country. Over 50% now say we should regulate carbon dioxide and other greenhouse gases. It's interesting that only 25% say, yeah, I believe that climate change is due to humans. But 51% now say, and we should regulate carbon dioxide. There's only one reason to regulate carbon dioxide. That's because climate change is due to humans. So they can't say that, but they know it. And that means that even people who think maybe very differently from you probably don't think as differently as you might believe. And the conversations will be easier. Most important, talk with your peers. We need the youth voice to get very, very loud. It's your future. You have so much at stake. Okay, one thing you can do also to help your voice get heard is join what I call Climate Truth Organization. Sunrise Movement, pictured here, inside Nancy Pelosi's office. It's a youth movement. I can't join it. I can't be a part of Sunrise because I'm too old. You guys all can be a part of Sunrise. And in my opinion, Sunrise Movement is going to make the difference. It is the organization that has the best chance of saving your future and can create a local, I think they call them hubs. Get active. And when Sunrise organizes a march on Lansing, be there, or Washington. And the last thing is when you vote, choose your candidates based on their stance on climate change. Make climate change a major voting issue. The 535 people, 536 in those two buildings control your future more than anyone else on the planet. And we need to get into those buildings people who will stop the current generation from stealing your future and instead start protecting your future and making it as good as it can be. Your vote absolutely counts. The United States has done a radical shift or a dramatic shift, let's say, on climate policy because of people voting in November. And whether they intended to or not, a large enough number were climate voters. I think that to me is my number one voting issue. These are two of the possible futures that we have, that you have available to you. The left is Paris extended, the right is the future we're headed towards. The left is the one on the left is still a possible future, but we have to act quickly. This is going to happen a lot more if the future on the left, the Paris extended future, is actually going to become your future. You must play an active role in it. It won't happen without your voice. So that you're in the unfortunate position of being given a future that's just not fair. We by continuing to burn fossil fuels, every time we do, we are stealing a little more of your future, and we're dramatically damaging the planet in the long run. So that's a very bad situation for you to be in. On the other hand, you are probably the first generation that can legitimately accept as your challenge saving the planet. You are probably the first generation in history that can be the generation that saves the world. And of course, I'd be happy to help you in any way I can. One of the things you can do is share this information with people who you think it might matter to. And with that, I'll stop.
Thank you, Dr. Karowe. We got nine questions.
Cool.
All right. When the air holds 7% more moisture per degree increase, is it increase in Celsius or Fahrenheit?
It's per degree Celsius.
Second one is, how did they record the level of carbon dioxide up to 400 years ago?
400,000 years ago. Yeah, actually, we have it to at least 800,000 and generating carbon dioxide and methane and nitrous oxide levels back to 1,000,000 years ago. And the data come just like the past temperature data over that last, let's say, 800,000 years. It comes out of the ice cores that are drilled in the Antarctic ice sheet. It turns out that every year there's an annual ring added to the Antarctic ice sheet. Every year for the last 800,000 years, more snow has fallen during the Antarctic winter than has melted during the Antarctic summer. And because the surface melts a teeny bit during the summer, you actually get bands of higher density and lower density ice when the weight of subsequent snow, the snow from subsequent years, when the weight actually becomes so much that the snow gets turned into ice, you actually have thicker and thinner bands every year. So you've got annual rings. That means you can count back and say this ice was formed 397,457 years ago, plus or minus maybe 100 years, but really pretty close. The oxygen isotopes in that ice from that year tell you what the temperature was of the Southern Ocean, therefore probably of the planet. And every once in a while, about every 100 years, a bubble gets trapped. An air bubble is in the ice core. The ice core is like, it's less than a foot diameter. But every once in a while, there's an air bubble in there. You know by counting back when that air was trapped. You can pull the air out, run it through a CO2 analyzer, and get a read of the air CO2 levels, the atmospheric CO2 levels, when that ice fell as snow. So great question. We have annual records of temperature from the ice itself. We have about every century records of atmospheric composition. And temperature and CO2 have always gone up and down together.
All right. Next one is, would it be safe to assume that the Great Lakes would get smaller as the temperature rises under the business as usual model?
Yeah, excellent question. Evaporation definitely will increase. First of all, because the air temperature is warmer, so summer evaporation is going to be more. The ice cover on the lakes will be there for less of the time. So the lakes will be able to evaporate water for more of each year. The big questions, though, are what's going to happen to runoff into the Great Lakes? So if precipitation increases, and the prediction is Michigan will actually get a little more precipitation annually, but not what I showed was summer precipitation, which will decrease. So if there's more precipitation annually, how much of that ends up in the lakes? And that depends on two things. One is how much of that precipitation is coming down in extreme events where the water doesn't go into the soil, it goes into, let's say, the rivers that empty into the Great Lakes. And the other is what's going to happen to the amount of water that trees transpire. So their roots pull water out of the soil, goes up through the xylem and evaporates out of the leaves. That's evapotranspiration. And it turns out that as carbon dioxide levels in the atmosphere increase, the plants close their stomates, close the holes in the leaves more. And if they close the holes in the leaves, they don't transpire as much. The water can't evaporate out of the leaf. More of it stays in the soil, more of it can move from the soil ultimately to the lakes. So the bottom line is we've got three things going on: evaporation, precipitation, and evapotranspiration. And the general prediction is that Great Lakes water levels will decrease, but about a third of the models actually predict an increase. So my judgment at this point is we do not know because those three variables are involved, and evapotranspiration has only recently been identified as a contributor to future lake levels. I think there's a 2/3 chance maybe that Great Lake levels will decrease, maybe by as much of it as a meter, in which case, yes, the surface area would be much less, but there's maybe a 30% chance that Great Lakes levels will actually rise, which they have been doing recently.
All right. I'm gonna wrap things up. Thank you so much,
Sure.
and sorry about the time
Oh, my
confusing.
fault. Yeah. So I'm going to put my email address in the chat if anybody has questions that, or just want to pursue anything uh, related to climate change. You can always write me, and I would be happy to answer. You can also, of course, find me in the biology department at Western. You can always go there to find faculty.
All right, there's going to be a 15-minute break before session 3.
So Riley, am I free to attend other sessions now?
If you don't have anything